Hello everyone, good morning. Am I audible? Yeah, perfect. Okay, so let's begin with the session here. Okay, so in the previous, 3-4 days here, we spoke about, the kickstart for collections, and we understood what is collection, what is the difference between array and collections. Okay, and we saw the working of array list, linked list, vector. Okay, and the different constructors, methods, or whatever we have. Okay, so make sure try to go through it, and whenever you come across any doubts here, just drop me a mail or a message. Okay, we'll try to rectify it here. Okay, so in today's session here, we are going to talk about a very important topic here. Okay, for understanding the next 2 days. Okay, so that is nothing but set. Okay, what is set? The first point that should come to your mind here is set is a predefined interface in which package? In java.util package. Okay, because I told you majority of all the classes and interfaces that we use in collection is present in util package. So set is a predefined interface in java.util package. And when was it introduced from? It was introduced from JDK 1.2. Okay, so it was started from the JDK 1.2. Okay, and set is also a sub interfaces of collection. Okay, under collection we had three major sub interfaces, that is list, queue, set, and set is also one of the sub interfaces of collection. It's a predefined interface in java.util package, and it was introduced from JDK 1.2. Okay, if you just look at the hierarchy over here, we had collection. Under collection we had set here. Under set here, we have majorly three implementation classes here. Majorly, we have how many implementation classes? Three. That is hash set, linked hash set, and tree set. So these are the three, important interfaces, I mean, implementation classes under the set interface. So this is the hierarchy here. Collection is the supermost interface. Under collection, we have set. Under set, we had three implementation classes: hash set, linked hash set, and tree set here. Okay, so that is the most important part which we are supposed to understand here. Okay, and the next topic over here which we are going to, continue and understand here is, sir, why set, sir? Okay, why not list, sir? Okay, I'll talk about it. Okay, so now we have certain differences between set and list over here. We have certain differences. So the first difference is, whenever we talk about the insertion order, okay, whenever we talk about what? The insertion order here, the set does not maintain the insertion order, whereas the list used to maintain the insertion order. Clear? Similarly, whenever we talk about duplicates, okay, duplicate objects, duplicate elements over here, set does not allow duplicates, but list, it can allow duplicate objects as well. Okay, and the next point here is, okay, index based. Who was indexed based here? Okay, index based meaning based on the index position, I could retrieve the objects here. Set is not index based, but list is index based here. Okay, so these are the major differences between list and set. Okay, set does not maintain insertion order, does not allow duplicates, and it is not indexed based. But when you talk about null value, sir, can I insert null value, sir? Yes. Set will also allow null and list will allow null here. So these are the few, major differences between list and set here. But there's one common question they'll ask in an interview. Can I make use of get method on set here? Can I use get method in set here? Your answer is big no. Okay. Why? Sir, common sense, sir. Get method is used to get the data, get the object based on the index position. Since set is not indexed based here, how will you get the data here? You cannot get the data here. So we cannot make use of get method with respect to set here, because get method specification, the job of the get method is to get an object based on the index position. Since set is not indexed based, we cannot use get method over here. Okay. So then, sir, for traversing, what can I do, sir? For traversing, you can either make use of for each loop, okay, or you can either make use of iterators. Okay, you can either make use of for each loop for traversing or iterators for traversing. So these are the few things which we are supposed to know by kickstarting with something called as set here. Okay, so what are the few things we are supposed to know here? Set is a predefined sub interface of collection interface. See, set is a predefined sub interface of collection interface present in java.util package. When was it introduced from? JDK 1.2. And what are the implementation classes of set? Hash set, linked hash set, and tree set here. And what are the difference between set and list here? Insertion order duplicates, not index based. Okay, insertion order list will maintain, but set does not maintain. Duplicates list will allow, but set does not allow. Indexed based list, set no. Null, yes, we can use it. Can we use get method on set here? No. Why? Sir, set is not indexed based, sir. How can I use get method? Common sense, not possible. Okay, and if at all I want to traverse it, I have to make use of for each loop or iterators. So with the help of those, I can traverse the objects one by one in a beautiful manner. Okay. Now, so now we got the basic idea about set over here. Okay. Now here, okay, see here, I will talk about, okay, what is hash set over here. Okay, let us try to talk about what is hash set over here. So hash set is nothing but it's a predefined class in java.util package. Okay, it's a predefined class in which package? Java.util package, meaning it's an implementation class of the set interface. Okay, it's an implementation class of which interface? Set interface. When was it introduced from? This was introduced from JDK 1.2 here. Okay, it was introduced from which JDK? JDK 1.2. Okay, now here, when I create an object of hash set, okay, you have to understand real carefully. Okay, if I am creating an object of hash set, see here, hash set h equals to new hash set. It's an object, right? It's a class. So I can create an object of a class. So I will create an object of a hash set here. So internally, okay, internally the data structure is hash table. Internally, what will get created here? And hash table will get created. Okay, and the job of the hash table, okay, and the job of the hash table is to store the objects in terms of key and value pair. Okay, so always the job of an hash table is to store the key and value pair. Okay, that's the job of the hash table over here. Okay, that's the specification of the hash table. Clear? So what is the underlying data structure of hash set here? The underlying data structure is sorry, underlined data structure is hash table. Okay, so when I create an object of hash set, if I create an object of hash set, internally an hash table will get created, and the hash table is used to store the objects in terms of key and value pair. Okay, wherein the initial capacity, okay, the initial capacity is initial capacity is 16. So in simple terms here, when we create an object of hash set here, internally an hash table will get created. And what will be the size of that hash table? It can store 16 objects. Initially it can store how many objects? It can store about 16 objects here. So that's the specification about hash set here. Sir, what will be stored into the key, sir? And what will be stored into the value? So imagine I tell h.add of, okay, I am adding an object of employee. So I'm adding an object of employee. Okay, clear? I'm adding what? And I'm adding an employee object. So every key will always be the hash code of an object. What will be the key? The key will be the hash code of an object here. Okay, and the value will be the object itself. Okay, the value will be the object itself. So if I'm trying to add an employee object here, every employee object will have a unique hash code, unique ID. So the key will be the hash code of an object, and the value will be the object itself. So imagine I am trying to store Uday object. Okay, Uday object. I'm trying to store Uday object. Uday will get stored into the value part, but the hash code of Uday will get stored into the key here. So key is always the hash code of an object and value is the object itself. Clear? So what is the initial capacity? 16. Now imagine your hash table is full. Okay, your hash table is full, but still you try to add an object. Okay, you add an object once the hash set is full here. Now what should happen? A new hash set should get created, correct? So therefore, the fill ratio, okay, we have this concept. We have the concept as fill ratio or load factor, okay, of a hash set is nothing but 0.75 or it is 75 percentage. So it's going to increase its size by 75 percentage. What is 75 percentage of 16 here? What is 75 percentage of 16? It's simple. 16, if I divide it into four parts, okay? Four parts over here, 25, 25, 25, it's 100. So it's 4 plus 4 plus 4 plus 4. This is 25 percentage, okay? And this is 25 percentage. This is 25 percentage and this is 25 percentage. So when I add 25, 25, 25, 25, it's 100%. And 25 percentage of 16 is 4, 4, 4, 4. So if I want 75 percentage, I need to add those three. 75, 25, 25, 25, it's nothing but 12 here. So it simply means here 12 is the 75 percentage of 16 here. So the size of the new hash set will be 16 was the initial capacity plus 12. So the size of the new hash set will be 28. Why? Because it's increasing its size by 75 percentage. Okay. Therefore, it's going to have the new hash set size is 28. And I know you all know how to calculate the percentages. Okay. I'm very bad at it. That's the reason I did in one particular format. Okay. So make sure that's the reason I don't train on aptitude. Okay. So you know to calculate the percentages, no? The 75 percentage of 16 is 12 here. So it's going to increase its size by 75 percentage. The size of the new hash set will be 28. Again, it keeps on increasing based on the load factor. Okay. So that's what we are supposed to understand. Nothing much here. Okay. So whenever we talk about hash set, it's a predefined class in java.util package and it was introduced from JDK 1.2. What is the underlying data structure? Hash table means when we create an object of hash table, hash set, sorry, and hash table will get created and the initial capacity of the hash table is 16. So the hash table will always store the objects in terms of key and value pair. Okay. Once the hash table is full, if we try to add an object, it's going to increase its size by 75 percentage. Okay. And the key will be the hash code of an object and the value will be the object itself. Okay. So these are the few things which we are supposed to understand. Okay. And we also know what is upcasting, no? Okay. What is upcasting, no? See here. If I have a set reference here, if I have a set reference over here, I can store an object of hash set also. See here, I can store an object of hash set also. I can store an object of linked hash set also. And I can store an object of tree set also. Why? Because these three classes, hash set, linked hash set, tree set, will have the super interface called as set here. So therefore, creating an object of subclass and creating an object of subclass, creating an object of subclass and storing its address into a reference of type superclass. Now we are making the super interface. So it's like super interface reference sub implementation class objects here. So this way also we can achieve here. Okay. So these are the few things which we are supposed to understand when we talk about collection here. Okay. Now let me just go and explain a few programs under that. Collection is a framework, that project we created and we are done with 4 days. Now this is my fifth day. So here I'll have package day 5. Okay. Under day 5 here, let me create a package and the package name. Oh, we created a package already, right? We'll create a class. Class name is, we will give it as demo. Okay, I'll just give the class name as demo here. Okay. Perfect. Now here I will have my main method wherein the execution will always begin from the main method. Okay, so I have my main method wherein the execution starts. Okay, now here I will create an object of hash set. Hash set h equals to new hash set of. Okay, I create an object of hash set. But why is it giving an error? Sir, it's a predefined class in java.util package, sir. So we have to import it. Clear? Can I upcast it here? Can I store it into set reference here? Possible. But we have to import the set from java.util package. See, upcasting will work here. If I just write it as list over here, I have to import the list from java.util package. But still it gives an error. How? Because how is hash set related to list here? Common sense, no? The object of hash set, I can store it into the super interface or super class, that is set here. How can I store it into list here? I can't do it. Okay, this is a dabba fellow, guldu fellow will do like that. Okay, so just make sure, yeah, this is what we are supposed to understand. Here I'm just creating an object of hash set over here. Clear? And I have imported from java.util package as well. Now here h.add of, okay, I will write it as 20. As of now, heterogeneous, we all know it, right? Heterogeneous objects I can store. Okay, I'll keep on adding multiple objects here. Null over here, I'll add 20.67, and over here I'll tell h.add of java here. Okay, now I have added 5 objects. Now here guys, quickly tell me, if I tell h.size over here, what will be the output here? When I tell h.size here, what will be the output guys? Can you quickly tell me the answer over here? Tell me the size of this data here. Okay, quickly tell me. Hey, what should be the size? Actually, that's my simple question. Okay, now. So what will be the output here? Just tell me the output here. Okay. So everyone are telling it as 4 here. Why 4 here? See here. The output what I get over here is, okay, I get the output as 4 only. How did I get the output as 4? It's simple. Okay. The reason is because duplicates are not allowed inside set here. But I am trying to insert and duplicate object. So only once he will consider. So see here, when I just try to print this h over here, because the toString method is overridden, see what is the output I get here. See, if you could closely observe, the insertion order is not maintained. As I told you, insertion order is not maintained and duplicates are not allowed. So that's the reason here I get the size as, okay, this respective data. That's the reason I get this respective content over here. And if you want to traverse it with the help of for each loop also, you can do it. It's not that you have to always do it like this. Okay, you can make use of for each loop also and try to traverse the content here. Okay, so that way you can follow it. Okay, so if I want to traverse it with the help of for each loop, what will be the type guys? I have heterogeneous objects into my hash set collection. So what will be the type here? Can you quickly tell me? Because once I have heterogeneous objects, this is an integer object, double object, null means default value. Okay, this is an integer object, string object. So I can just write the superclass type, that is object type reference over here, obj colon from the hash set h here. And over here, I'm just trying to print the object reference. So I can traverse it with the help of for each loop as well. So I will definitely get the output here. Yes, so insertion order not maintained, duplicates not allowed. It is definitely not indexed based. Okay, and then null values can be inserted. So these are the few things which you are supposed to understand when we talk about hash set over here. Okay, but now over here, after this entire process over here, okay, majorly, okay, so we are supposed to understand one more part. What is it over here? So it's linked hash set. Okay, it's nothing but linked hash set. It's very simple guys. Okay, linked hash set. Okay, nothing great over here. Okay, when I talk about linked hash set over here, it's very simple. It's a predefined class in java.util package. Okay, when was it introduced from? JDK 1.4, not 2. Okay, it was introduced from JDK 1.2 here. The only difference between hash set and linked hash set is, okay, the only difference between hash set and linked hash set is, hash set, it does not maintain insertion order. But linked hash set will maintain the insertion order. That's the only difference between hash set and linked hash set here. Okay. So now let me just cross check over here. Let me just prove it to you. Okay. I will have one class and the class name is test class over here. Okay. Now I will have my main method wherein the execution will begin from. So here I will create an object of linked hash set. See, linked hash set LHS equals to new linked hash set. Okay, I'm just creating an object of linked hash set. Okay, so yes, perfect. And I'll just set it as LHS. So I have to import it from java.util package here. Okay. Now here, can I make use of generics and tell please allow only string objects here? Yes, you can tell. Just after the class name, okay, I will just try to write it as string over here. Okay. Now, after this entire process over here, I can make use of generics as well. So I can just do this entire data. Okay. But now over here, after this entire process over here, okay, see here, I'll tell L dot, LHS, dot add of, okay. I'll just add one string data here, okay. I'll just write it as Java over here, okay. And then over here, I'll just try to add Java, Python, a lot of data over here. I'll just write it as Python over here, and I'll just write it as Java script over here. Okay, Java script over here, right? So I can traverse it with the help of for each loop here. Okay. So now here, since I have only string objects into my collection, I can make use of collection subject colon. Okay, string subject from LHS here. So when I just try to print the object reference here, that is subject here, I will try to get the output. When I execute this entire process over here, I'll get it as C, Java, Python, JavaScript. But the only reason over here, I told you that set will not maintain the insertion order, correct? Absolutely valid. But over here, the problem here is since we are making use of linked here, a linked hash set is a combination of linked list as well as hash table internally. It's a combination of nodes as well as hash table. So that's the reason it maintains insertion order, but it does not allow duplicates. Okay, so it contradicts here. Okay, but we are just supposed to understand in this particular way. If I make use of just linked list over here, duplicates will be allowed over here. Okay, duplicates will be allowed here. But if I want to avoid duplicates here and still maintain the insertion order here, then I have to always choose linked hash set over here. The most important part is, see, the insertion order is maintained, but it does not allow duplicates. So that's how, we are supposed to understand. If you just cross check the difference between linked list, hash set, linked hash set, see, linked list, insertion order is maintained, but still duplicates are also allowed. But hash set, no duplicates, no insertion order. Okay. But if there is a necessity wherein I have to maintain the insertion order, but duplicate should not be allowed. Therefore, I have to choose linked hash set. So based on certain requirements here, we have to just understand it. But the internal algorithm, the data structure which the Java people have developed, that's how they have developed. So if you want to just have a look at the source code here, press Control on the keyboard, hover on the class name, click on it. So if you just look at, see, it is passing this entire data. Okay, it's 1.4. See, it's implementing set, clonable, blah, 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 blah. And if you just cross check over here, see, initial capacity, as I told you, it's 16. Okay, generally it starts from 16 here. And it's going to increase, I mean, if we go here, the underlying data structure will be something else. Okay, so that way they're just going to understand this entire process over here. Okay, so this is just the basic things which we are supposed to understand when we talk about hash set and linked hash set here. Okay, but now there is one question which will you should get to know here. Sir, you told here, okay, how will set maintain uniqueness? Okay, that's your question. Okay, imagine that's your question here. How will it not allow duplicates? How set maintains uniqueness over here? Okay, how does it not allow duplicates over here? Because internally there are two methods which are responsible for it. One is called as hash code method and another one is called as equals method. So these two methods are overridden internally. That's the major reason over here Has set does not allow duplicates here. Okay, set maintains uniqueness. That is, it does not allow duplicates. Why? Internally, the hash code method and equals method are responsible for performing this action here. Okay, so if you just want to have the basic idea about it, I will tell you here. See here, I will create an hash set object. Hash set h equals to new hash set of. I create an object of hash set. So internally what will happen? And hash table will get created. And hash table will always store the data in terms of key and value pair. Okay, he will store the objects in terms of key and value pair here. Okay, this is all about it. This is key and this is value. Imagine I have two employee objects. Okay, how many employee objects? Three employee objects. E1, E2, E3. So there are three employee objects. This is E1, E2, E3. And all the three objects will have a unique hash code. That is 111, 222, 333. Okay. So 333. Every, all the, objects will have a unique hash code. That we know it, right? So therefore, okay, therefore here, now when I tell h dot add of, okay, h dot add of, I am adding the first object. That is E1. I am adding the first employee object. So now slowly it goes here. It goes here. So what is the hash code of E1 here? It's 111. Okay, it's 111. It checks in the key part, is there an hash code by the name 11111 here? No, it's not there. So 111 will get inserted and the respective value is E1. Meaning I'm just checking, okay, equals method. Is 111 equals any of this content in the key? I'm just checking, okay. It's not there. So 111 will get inserted. Now for the second step. H dot add of I am adding employee to object. Slowly it goes here. Okay. What is the hash code of employee to? It's 222. So internally it checks is 222 is present in the key here. Is 222 equals 111? No. Is it available? No. So E2 also will get stored and that particular employee object will get stored here. Again, for the third scenario, when I tell h dot add of, okay, E1, I am adding employee one object once again. So now it goes here again. It checks here. What is the hash code of employee one? 111. It checks is 111 present in the key. Yes, 111 is already existing in the hash table. So this particular object will be discarded. It will not be added at all. Why? Because equals method found that 111 is already there here. Why will it enter again? So he will check this hash code. See, hash code method and the equals method are responsible for maintaining the uniqueness here. So they both have been overridden. So that's the reason here hash set will always maintain the duplicate. I mean, it will not allow duplicate set. Okay. Now when I try to add the third object, h dot add of, okay, E3. So I'm adding the employee 3 object. It checks here. The hash code is 333. I will check with all the keys here. Is 333 dot equals 111? No. Is 333 dot equals 222? No. And I'm traversed with everything. So it's not available. So therefore 333 will get inserted and the respective object here. So when I try to enter 333 once again, E3 once again, it checks 333 equals 111? No. 333 equals 222? No. Is 333 equals 333? Yes. So 333 object is there. So therefore it will not get inserted. So that way it will always maintain the uniqueness, meaning it will not allow the duplicates. So which two methods are responsible for avoiding duplicates, for preventing duplicates, maintaining the uniqueness? Hash code method and the equals method. If that particular hash code is present in the set, it will not enter. If that hash code is not there, that is wherein that object will get inserted. If the hash code is existing, it will not store. If the hash code is not available, that is when it will store here. This is how it will maintain the uniqueness here. Clear? This is all about the entire process here. Clear? So now here we just got the idea about what is hash set, what is linked hash set and all those. Okay. And we have a few set of constructors over here as well. Okay. So linked hash set also has a few constructors, and if you want to cross check how do you find out the constructors, you have to just tell new hash set here and just tell control space bar. So once you tell control space bar over here, can you see so many hash set here. See, hash set of constructs a new empty set here. Okay, backing hash map. Hash map means hash table. And what is the default initial capacity? 16. And the load factor is 0.75. And when I make use of the second constructor over here, second constructor, it's nothing but we are trying to add one collection into another collection. And then initial capacity means we can explicitly pass our own initial capacity. Okay, specified initial capacity I can pass, but I can have the default load factor is 0.75. But I can have the next constructor as well, these four constructors over here, wherein I am explicitly passing the initial capacity as well as the load factor here. Okay, so this is what we are supposed to understand, meaning an object, an instance will get created over here. Similarly, if you want it for linked hash set, you can check. See, linked hash set. See, again, we have the same four constructors. As I told you, linked hash set and hash set is almost same. Okay, but the only difference is hash set does not maintain the insertion order, but linked hash set maintains the insertion order. Clear? So if you just want to, have a look at all the four constructors here, you can make use of this. See here, these are the four constructors here. Hash set of, wherein an empty hash set will get created, meaning hash table instance, okay, hash map instance will get created, wherein the initial capacity is 16 and the load factor is 0.75. Okay, and then hash set of, we can add only int initial capacity. We can pass the initial capacity over here. Clear? So wherein the load, whatever initial capacity I pass at 20, that will be the specified initial capacity, but the load factor will always be same here, because I can pass customized hash set size here. Okay, and the third is hash set of, I can pass the int initial capacity. I can specify my own initial capacity, as well as I can also give my own load factor as well, meaning what is the ratio. So if I pass hash set of probably, okay, I'll tell the initial capacity is 10 and it has to increase the size by 1.5. It's 150. The increment is 150%. So it's increasing its size by 1.5. And hash set of collection means we are adding one collection into another collection here. So these are the four important constructors which we have with respect to hash set. When I just create an empty hash set instance here, default capacity will be 16 and the load factor will be 75. Here, if I pass the initial capacity, I am giving my own specified initial capacity, but the load factor will be the default one, 0.75. And I can also pass the explicit initial capacity and the load factor as well. And collection C is nothing but I can add one collection into another. The same thing will work for linked hash set also. The same thing will work for linked hash set. So these are the few specifications about set here. Okay, but we are done with everything. But the most important part which we are supposed to discuss is tree set. This is what we are supposed to understand now. Tree set is what we are supposed to understand in a beautiful way, because tree set is the prerequisite for the next two sessions. Comparable comparator you will understand only when you know tree set. If you do not know tree set, trust me, you will never ever understand the next 2 day session here. Okay, we'll never understand. Okay, so let us just summarize whatever we learned now, and then we'll quickly jump into the hash set part. Okay, tree set part. Okay, so first of all, guys, we started the session with something called as set. Okay, in today's session, we're going to complete set here. Okay, set is an interface present in java.util package, introduced from the second version of Java, that is 1.2. So we know the hierarchy over here. Since set is not indexed based, we cannot use get method. Okay, and we saw the difference between list and set also. And now we saw the specifications of hash set. It's a class. Okay, when I create an object of it, internally an hash table instance will get created. Hash map you can tell. Okay, but internally you tell it as hash table. The initial capacity is 16, but the load factor is 0.75. Okay, and this is the same specifications with respect to linked list also. Linked hash set, sorry. Linked hash set and hash set are same, but the only major difference is insertion order. Linked hash set maintains insertion order and hash set does not maintain. Okay, and we saw how does hash set maintains uniqueness, meaning set maintains uniqueness, because hash code method and equals method are overridden internally. So if the hash code is not available, it's not present, that is wherein that object gets inserted. If the hash code is present, he will not insert the object here. Clear? And then we also saw a few set of constructors as well. Okay, we just saw the constructors as well. Okay, so this is all about, okay, set, hash set and linked hash set. Now the most important and the beautiful part which we are going to understand is tree set. So concentrate for the next 15-20 minutes. You have to concentrate completely, okay, without thinking about anything here. Just concentrate. Okay, so first of all, guys, whenever we talk about set, okay, whenever we talk about tree set here, it is a predefined implementation class, okay, present in java.util package only. So this tree set is a predefined class, okay, and that's an implementation class of the set interface, okay. And when was it introduced from? It was also introduced from JDK 1.2. Okay, it was also introduced from JDK 1.2. Okay, but what is the speciality about tree set? Okay, let us do it into a programmatic manner. Control N, I create a class and the class name is runner class. So now here I'll have my main method over here. I'll have tree set over here. Tree set t equals to new tree set of. Okay. Now here I want to store only integer objects. I will import it. I want to store only integer objects into my collection. So I have to make use of integer because the wrapper class. Okay. Done. So you can use it at the constructor side also, but it's optional. So I'll tell t dot add of, I'll tell it as 40. Okay, I'll tell it as I'll write it as 30 over here. T dot add of, I'll write it as 40 now. T dot add of, I'll write it as 20. T dot add of, I'll enter 30. T dot add of, I'll write it as 50. Okay. T dot add of, I'll write it as 10 here. So now when I traverse it with the help of for each loop, it can either be int or integer, doesn't matter, because auto boxing, unboxing will happen internally. So when I just try to print this respective content over here, look at the output what I get here. So I got it as 10, 20, 30, 40, 50. So what did you understand? What did you understand, guys? Okay, what will the tree set specification do? Okay, so the tree set will always maintain the sorted order. Okay, natural sorting order, that is nothing but ascending order here, but duplicates will not be allowed. Okay, so the major difference between hash set, linked hash set and tree set is hash set does not allow, does not maintain insertion order, linked hash set maintains insertion order, and tree set is sorted order. Okay, tree set is sorted order. So these are the three differences here. But now we understood everything over here. We understood everything. But now here we have to understand the working of tree set here. Okay, that is wherein you will understand comparable and comparator beautifully. Okay, so I go back to my theoretical part. Okay, I go back to my theoretical part here. So whenever you add an object into tree set, okay, whenever I just add here, okay, whenever we add an object, okay, whenever we add an object into tree set here, internally one method will get called. Okay, internally one method will get called, and that method name is compare to method. Okay, that compare to method will return an int value. Okay, so that int value is, okay, I'll just write it as, it's +1 if it is greater than, -1 if it is lesser than, and 0 if it is equal to. So I repeat, whenever we add an object into tree set here, the compare to method will get called. Okay, the compare to method will always return +1 if it is greater than, -1 if it is lesser than, and 0 if it is equal to. Okay, and the underlined data structure of tree set is, okay, underlying data structure is binary tree here. Okay, internally binary tree is the data structure which the tree set is going to use here. Okay, now let us try to understand each and every specifications over here. Okay, so closely observe, guys. Okay, this is very important. Step number 1. Okay, t dot add of, okay, I am adding an object into tree set, that is nothing but 30. So the first object will get stored as it is. Just assume that, okay? 30 will get stored into the node here. Okay, binary tree got stored as the node here. And what is the next object I'm adding? 40, 20, 30. Okay, done. Okay. Next here, step number 2. Okay. So step number 2 is nothing but t dot add of. Okay. I am adding 40. Correct? I am adding 40. So what did you understand? When you add an object into tree set, which method gets called internally? Compare to method. Clear? So which is the object getting inserted? 40. 40 is the object getting inserted. Dot compare to. Okay? Compare to the already existing object, that is 30 here. Okay? So now I check here. Is 40 greater than 30? And 40 minus 30 is always positive value. See, if 40 is greater than 30, it will return plus 1. So 40 minus 30, it's plus 10. It's a positive value. If it's a positive value, always the node moves towards the right side. So from 30, the control will go to the right side, and wherein 40 will get stored over here. What will get stored? 40 will get stored into that respective object here. Clear? Step number 2 done. And step number 3. Okay, third step. What is the third step here? T dot add of. Okay, I am adding 20 here. Okay, now when you add an object into tree set, which method will get called? Compare to method. Which is the object getting inserted? 20 dot compare to. Okay, I have to compare with the already existing object. But I have two objects, 30 and 40. I have to always compare with the root node. The root node is 30. So I have to compare it with 30 here. So here 20 is lesser than 30, and okay, 20 minus 30 is minus 10 here. So minus 10. So 20 lesser than 30 will return minus 1. It's lesser than minus 1 and minus 10. It's a negative value. If it's a negative value, it will always move towards the left side. So from 30, the control will come over here and 20 will get stored here. Clear? Perfect. We are done with step number 1 here. Okay, so we're done with step number 1. Okay. After this here, what is the next step over here? I am telling fourth step. The fourth step is t dot add of. Okay. T dot add of. I am writing 30 over here. I'm adding one more object. So when you add an object into tree set, compare to method will get called. So here 30 is the object getting inserted. Compare to the already existing root node is also 30. So therefore it is also 30. So is 30 equal to 30? Yes. 30 minus 30 is nothing but 0. It is 0. If it is 0 here, discard. Meaning 30 is already existing. Okay, so therefore we are not going to insert 30 again because it was same. 30 is already existing. So is 30 equal to 30? Yes, it's written 0. 30 minus 30 is 0. So you'll always return discard here because it is same here. Clear? Next, the step number 5. Okay, step number 5 is what is really important. Okay, t dot add of. Okay, let me see which is the object I'm adding. I'm not sure. It's 50 and 10. Okay, so here I will add 50. So when you add an object into tree set here, which method will get called internally? Compare to. 50 dot compare to. Okay, 50 dot compare to which object? Root node 30. So what does it mean? 50 is greater than 30, so it will always return plus 1. And again 50 minus 30, if you subtract also will get plus 20, positive value. If it's a positive value, it has to always go towards the right side. So it was compared with the root node, so it goes to the right side. But we have one more node over here. So now it has to get compared with that node now. So 50 is the object getting inserted. Compare to, okay, compare to 40 here. So it's simple. 50 is greater than 40. That is nothing but 50 minus 40. So that is nothing but plus 1. And this is plus 10. So again, it's a positive value. So it will go to the right side. So from 40, it comes towards the right side and 50 will get stored here. Clear? So we got the clarity. And what is the last step over here? Okay, there's no space here, guys. So let me just write it the sixth step over here. Okay, T dot add of. Okay, I am adding 10 over here. So when I add an object, into tree set, compare to method will get called. 10 dot compare to. 10 is the object going to get inserted, dot compare to 30, because I have to compare with the root node. Clear? So now here 10 is lesser than 30. Okay, that is nothing but minus 1. 10 minus 30, I will get minus 20. It's always negative value, so it has to go towards the left side. So from 30, I compared with the root node. It comes to the left side. But we have one more node over here. So now what should happen? It should get compared with 20 over here. So therefore, 10 dot compare to, okay, 20 now. So when I get compared to 20, 10 is lesser than 20. 10 minus 20 is also negative value. Minus 10, minus 1 here. So therefore, it again moves towards the left side because it's a negative value. So control will come over here and this data will get stored here. So I got this particular data. Okay. And the sorting order is, okay, the traversing order, okay, which we are going to follow in tree set is, we have so many traversing order, pre-order, post-order, in-order. But the traversing order which we follow it in Java is in-order traversing. So in-order traversing meaning left node, okay, parent node, left node, parent node, and then the right node here. Okay, left node, parent node, right node. So if I go back over here, okay, 10. Okay, it's the left node. Then parent node 20. Does it have right node? No. Then 30. Okay, does it have right node? Yes. Does it have left node? Yeah, 40 and 50. I'll get it in sorted order: 10, 20, 30, 40, 50. So if you have this data here, see, if I have the data as 30, 10, and yeah, 30, this is what the content is. No, see here, if I just have this content over here, 30, if I just write it as 20 and 40 over here, this is the order: left node, parent node, right node, 20, 30, 40. See, if I just go back over here, 20, 30, 40, left node, parent node, right node. So that will be the traversing order. So therefore, when I go back to my Eclipse over here, when I execute it over here, can you see I get the sorted order over here? Yes. So that's how, a tree set is always going to maintain the sorted order over here, ascending order over here. Okay. So this is what we have understood with respect to this specific content here. Okay. So what is the most important thing you need to understand? Whenever you add an object into tree set, compare to method will get called here. Okay. So compare to method is nothing but it returns an int value, integer value. Plus 1 if it is greater than, move towards the right side. Minus 1 is lesser than, move towards the left side. If it is 0, it's equal to. 0 means equal to, so discard. So it's already existing. Okay. The underlying data structure is binary tree internally, and binary tree is only getting executed. And what is the traversing order here? Left, parent, right. Okay. Left node, parent node, and the right node is the traversing order here. So this working is very important for your understanding of comparable and comparator later. Similarly, I can do one more program for you all. Okay, see here, I'll take the class name as solution over here. Okay, so now I will have my main method. Okay, so I will create an object of tree set. Tree set. Okay, so I will have only string objects now. Okay, t equals to new tree set of, we are creating an object of tree set over here. Okay, so I'll just create an object of tree set and I'm going to add only string objects into my collection here. Okay, now after this entire process over here, okay, we just got the basic idea. Okay, so now here I'm going to add string object. See, t dot add of, I'll write it as b. Okay, you can write it as whatever you want, banana, whatever you want. I'm just taking it as b because I'm going to trace this program also, wherein it becomes easy for me. Okay, that's the reason. Okay, I don't want to take complicated examples and try to confuse you all. Okay, so when I try to add this bca over here, when I try to print this t, because the toString method is overridden, so when I try to print this reference over here, I will get the output as a, b, c here. It means sorted order. You can do the same thing with respect to for each loop as well. Okay, you can sort it with the help of for each loop as well. Okay, So now if you want to traverse it, you can make use of for each loop also. I'll tell for open parenthesis close, open curly braces close here. So string type of objects S colon from the tree set T. So when I try to do this S over here, I will get the output here. See, I'll get the output as A, B, C, sorted order. You can give it as big datas only. You can give it as banana over here. Okay, you can give it as cat over here, and you can give it as apple over here. It doesn't matter. It doesn't matter if you have the content here. But I'll get the output as apple, banana, and cat because it's sorted order. Okay. So now here, if I go back to the tracing part over here, okay, and if I want you, I mean, if I want to explain the working of it, it's very simple over here. Okay, so try to concentrate here. See, when I tell t dot add of a, I'm adding a string object. Imagine it's apple only. Okay, but simple terms here. When you add an object into tree set, the compare to method will get called. But since it's the first object over here, it will get inserted as it is because there's no other object stored, no. So therefore, that a gets stored here. Okay, apple gets stored here. Okay. Now the second part. Second part is t dot add of. Oh, I'm not adding a here. Okay, I'm adding something else. I believe I'm not adding a, guys. I added which object here? Wait. I added b, banana. Okay, so I'm adding b over here. So the first object which I enter, will get stored as it is. Okay. Second time, t dot add of, I am adding, okay, c over here. So now here, what did you understand here? When you add an object into tree set, compare to method will get called. Now c dot compare to, the object going to get inserted is c, it has to get compared with b here. Okay, c dot compare to b. How will it get compared here? Do you all know the ASCII value of c here? What is the ASCII value of c here? Can you all tell me the ASCII value of c, guys? What is the ASCII value of c? A, uppercase A is 65, 66, 67 here. So it's for B here it is 67. 67 dot compare to, okay, B. What is the ASCII value of B? It's 66. So 67 is greater than 66, it will return plus 1. 67 minus 66, again it will return plus 1. If it's a positive value, it has to move towards the right side. Correct. So therefore, the control from here moves towards this data C over here. C will get stored into the right side. And then the third step. Okay, what is the third step? T dot add of, I am adding A over here. So now internally what happens when you add an object into tree set? Compare to. A dot compare to. Okay. B over here. Always the root node should get compared, guys. Okay. So now over here, A ASCII value is 65 and the B's ASCII value is 66 here. 65 is lesser than 66, it's minus 1. 65 minus 66 is minus 1. If it is minus 1, it is LHS. So the control will come over here, the output will be A here. So what is the traversing order over here? Left node, parent node, right node. A, B, C here. So that's the reason here I'll get the output as A, B, C, apple, banana and cat here. Clear? Now if I just give it as lowercase a over here, so just observe what will happen here. It is banana, cat and apple here. Why? Because the ASCII value of A, okay, apple, I mean A here is 97. So this is 66, 67 and 97. So it's going to get sorted in ascending order. So you have to be, so internally it's proven that it is going to sort based on the ASCII value. So that way we're just supposed to understand and get the clarity about this entire process here. Clear? So this is what we are supposed to understand. Clear? So everyone got the clarity about the working of tree set, guys? Any confusions here? Quickly tell me here. Any questions? Quickly. Any questions here? Anyone? Okay, great. Okay, so we just got the clarity about what is this tree set and how it is maintaining the sorted order. But now, so I told you that whenever we add an object over here, compare to method will get called. Correct? Whenever we add an object into the tree set, compare to method will get called. Where is this compare to method present here? Where is this compare to method present here? Any idea, guys? Any idea where is this compare to method present? I told you a compare to method will get called, but where is it present? So I will tell you here, closely observe. Compare to method is present in an interface called as, okay, in an interface called as comparable. Okay, it is an interface called as comparable. See, compare to method is an int method present in an interface called as comparable. But sir, in an interface we can have only abstract methods, right? So where is this business logic for comparison written here? Where is the business logic for comparison written over here? It's very simple here. See here, when I tell t dot add of, okay, when I tell 10 over here, it's nothing but t dot add of, I am adding an integer object, correct? New integer object, correct? Similarly, t dot add of, if I tell 10.5, it simply means t dot add of, I am adding one double object over here. I am adding one double object, that is 10.5 over here. Clear? If I tell it as t dot add of, okay, uh, Java over here, it's nothing but a string object is getting added. Okay, the string object is getting added here. So new string of Java here. Clear? This everyone knows, right? Because collection, it means it's completely non-primitive. Okay. When I add 10, it's an integer object. 10.5, double object. Java, it's a string object. Clear? So whenever you add an object into the tree set here, I mean, it is getting converted to its respective non-primitive type. So all the wrapper classes and the string class, I repeat, all the wrapper classes and the string class, okay, will implement the comparable interface internally. Okay, all the wrapper classes and the string class implements the comparable interfaces internally, and it has overridden the abstract method. Therefore, the logic is provided. Clear? For example, I'll show it to you. See here. If I just tell string, if I just press control, hover on the class here, click on it. See here, string is a predefined class. Can you see? It is implementing an interface. It is implementing an interface called as comparable. Inside that comparable, if you want to check, press control, hover on the interface, click on it. See, comparable is the interface, okay, and it has one abstract method. What is that abstract method? We have to see. What is the abstract method? Compare to. It is returning an integer. What is this t? I'll tell you later. Okay, compare to is the method and int. So when the string class, okay, when the string class is implementing a comparable interface, it should have overridden the abstract method called as compare to, no? So if you want, you can just write this data here. If you want, cross check. See here, it has overridden the compare to method somewhere. Yeah, see, can you see here? The compare to method has been overridden and it has found out the logic for comparison. See, so many internal logic they have done. Clear? Ultimately, if it returns the len1 minus len2 blah blah blah, we're getting the ASCII value here. Clear? Similarly, if you want to check the integer over here, I can do it. See, integer I equals to, okay, integer I, declare it. So when I tell this part here, look here, integer class also is implementing an comparable interface and it has overridden the business logic for, okay, compare to method. Yeah, see, compare to method, it is overridden. See, it's telling compare blah 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 blah. So it has overridden the compare to method here. Got it? So this is what we are supposed to understand when we talk about this data here. So when I tell, okay, when I tell here, okay, we are adding, see, when I tell which compare to method will get called, it's very simple. When we are adding the integer object, when you are adding 10, it's an integer object. It will call the compare to method in the integer class. If I add 10.5, I am adding a double object. It is calling the compare to method of the double class. Okay. And if I add Java, it's a string object. So internally it calls the compare to method present in the string class. Why? All the wrapper classes and the string class is implementing the comparable interface and it has overridden the compare to method to provide the business logic for comparison. Got it. So this is what we are supposed to understand. Never ever forget this point. Where is compared to present? In a comparable interface. All the wrapper classes and string class will implement the comparable interface and override the compared to method by providing the business logic for comparison. So if I add an integer object, compared to method in integer class. If I add a double object, compared to method in double class. String object, compared to method in string class. Okay. So this is what we are supposed to understand. If you want to cross check over here, okay, just look here. Control N. I will create a class called as main class over here. Okay, I'll create a class called as main class. In the main class over here, I will have my main method. Okay, I'll have my main method wherein the execution will begin from. Okay, so over here, see here, string A equals to I'll write it as A. Okay, string B equals to B over here. So I'm just writing it as A and B here. So sys out, I will tell A dot compare to B here. I'm comparing both the strings here. A dot compare to B here. So here I'll tell B dot compare to B. Here it is B. And if I go on the top, it's B dot compare to A here. Can you tell me what will be the output of this program here? A dot compare to B. It means A dot compare to B. So A's ASCII value is 65. B's ASCII value is 66. Is 65 lesser than 66? Yes, we get a negative value. So therefore it should be -1. B dot compare to A. What is B? It's uppercase B. Okay, B, it's 66. Dot compare to A. It's 65. 66 is greater than 66. It's always positive value. It is +1. Okay. B, it's B. B dot compare to B, it's same. So it will always return 0 here. So when I execute the program here, did I get the output here? See, -1, +1 or 1, it's same. Positive value and 0 here. So that way we got the output here. Similarly over here, okay, if I write it as int x equals to 10 and int y equals to 20. So now here, if I tell sys out x dot compare to, okay, y here, it is giving me an error here. Can you tell me the reason why? It's giving me an error here. Can you tell me the reason why, guys? Any idea why is it giving an error over here? Think and tell me. I'm not going to answer until and unless you tell. Okay, just think and tell me why is it giving an error. Very good, very good, very good. Okay, you people are answering. Sir, int is primitive. Primitive means it's just a keyword. It does not have any methods at all. So therefore, okay, I have to make it as integer over here. Make sure this is a non-primitive declaration. Okay, and over here also I'll just make it as a non-primitive declaration. If integer is a class, it should have so many methods, no? So when I tell x dot compare to y, it is calling the compare to method in the integer class. A dot compare to B, I'm calling the compare to method in the string class because this is non-primitive. So non-primitive means it's a class. So we can call all the methods here. So x dot compare to y, what will be the output here? Okay. Any idea, guys, what will be the output for the first instance here? So I'll write y dot compare to x here and x dot compare to x here. What will be the output for the first, this part here? Will it be -1 or +1? See, 10 dot compare to 20. So 10 is lesser than 20. So therefore, if it is lesser than, it will return -1. Y dot compare to x here. It's 20 dot compare to 10 here. So 20 is greater than 10 here. So it will return 1 here. So x dot compare to x here, 20 dot compare to 20, it will always return 0 because it's always the same here. Guys, we have already done this, okay? It's not a new thing, we're doing it here. Just a few minutes ago here, I explained it to you all. See here, what is it here? 40 dot compare to 30. 40 is greater than 30, it returns +1. 40 minus 30 is +1. So it's a positive value. If I just do it that way, see 20 dot compare to 30. So it means 20 is lesser than 30. So 20 minus 30 is -10. It's a negative value. Got it? So if it is lesser than -1, greater than, it is +1. If it is same, it's 0. That way you're just supposed to understand and get the clarity. See, I got the expected data. Similarly, last example, okay. Similarly, last example, I'm not going to give more examples here. Just see, double I equals to 2.4, okay, and double j equals to 3.5, okay. So I'll just write this entire data. Now I will tell sys out I dot compare to, okay, compare to j over here. Why am I getting an error here? Now at least you need to tell, why is it giving an error over here? Tell me guys, why is it giving an error over here? Okay, if I just hover on it over here, okay, it's telling because j, this is double is primitive over here. So if I just tell cannot invoke compare to method of double, it's a primitive type double, so it's only telling it's primitive type. Primitive meaning where will it have methods and all? It's just a keyword, it's not a class. So we have to write it as uppercase T. If I write it as uppercase T, I'm referring to the non-primitive reference, that is the primitive class. Okay, so that's the reason here we have non-primitives over here. So that's the reason collection supports non-primitives. Why? Because internally it calls compare to method and all, right? So that's the reason here collection supports only non-primitives, because internally there is a lot of algorithms, data structures, methods getting called here. So if it is specific that, we can easily do it. If not, it becomes a problem. So that's the reason here we are supposed to understand. So when I executed, did I get the output? -1, because 2.4 is lesser than 3.5, -1. 2.4 is equal to 2.4. So it's 0. It's 3.5 greater than 2.4. It is giving me the data here. Okay, I got the output here. -1, 0 and 1 here. Clear? Perfect. So this is a very, very good question here. Sir, what if I want to add heterogeneous objects into my tree set, sir? Is it possible? Okay, I'll tell you. See here, you will create tree set. Okay, t equals to new tree set of, okay, tree set of t dot add of, I'll add 10, t dot add of, I will write it as false, t dot add of, I will write it as dinga, okay, and I'll add t dot add of, okay, I'll add it as 10.5. So I am adding all the objects into my collection, into my tree set. When I execute it, I'll get a huge exception. And this exception you're all familiar with. Okay, when I try to add heterogeneous objects into my collection, we will get an exception. See, when I executed, did we get an exception? Yes. I told you you're familiar with that exception. Class cast exception, we all know it. Okay, so that it's telling here, how is it comparable? How can I compare integer value with Boolean value? So it's telling you have added 10 and false here. How will you compare an int value and false value? How, on what basis will you try to compare and sort them? So that's the reason it will not, I mean, if I remove this, again, when I execute it here, it will tell on what basis will you compare the integer value and the string value. Okay. So that's the reason here, okay, we are always supposed to store only homogeneous objects into my tree set. Why? Because only when I have homogeneous objects, I can compare them on one particular basis and try to sort them. If I don't compare them, okay, how will I sort them? So that's the reason here. So I cannot store heterogeneous objects into my tree set. Why? Because it's ultimately going to get compared and sort. If I don't do this way, how will it happen? So that's the reason tree set will always allow only homogeneous, not heterogeneous. Clear? So this is all about the entire process here. Clear? So anyone having any questions here? Okay. So the basic concept of collection fails here. Simple. It depends, It's not that it fails here. See, it's common sense here. Okay, it's not failing over here. It's common sense over here. The job of tree set, okay, is to sort. If I have heterogeneous objects here, how will it sort? On what basis will it sort? So therefore, it's a problem. That doesn't mean here we cannot store heterogeneous in objects in other types of collection. We can store, but it's not that completely it stores here. If you want to store heterogeneous objects only, use set, hash set, linked hash set, array list, vector, stack, blah, blah, blah. But here in tree set, since it is sorting internally, the major goal of tree set is to sort internally here. So therefore, we cannot have heterogeneous objects. Because we cannot see, it's not failing over here. See, tree set, I am adding all the heterogeneous objects only. It's not failing, okay? But only when I execute here, during execution here, the logic is to compare. compare and sort them. On what basis will you sort here? So that's the reason it's not allowing. See, if it was only homogeneous, it would have given an error in during compile time only. If it was failing, it's not failing here, okay? But internally, the algorithm is different way. Okay, we can add heterogeneous objects, but it won't sort. That's the only problem. Okay. So this is all about the session for today, guys. Okay. So anyone having any questions here? Anyone having any questions here with respect to today's session? Any questions, anyone? Guys, any questions? Okay, great. Okay. So in today's session, we have just seen what is set. Okay. We understood the working of hash set, linked hash set, and tree set. Okay. And the most important topics we have discussed. Okay. So the tree set, whatever I did from the the second half of the session here, it's going to be really important for tomorrow's session. If you fail to understand today's session, trust me, tomorrow's topic will go over your head. Okay. So make sure practice it here, okay, because it's going to be really important for you tomorrow. Tomorrow is the actual fun, okay, wherein you can compare student objects, okay, employee objects, and try to sort them. Okay, that way it's going to be really interesting here, and that is what we are going to use it in the real time as well. Okay, how I will tell you in tomorrow's session. Okay, so great guys. Okay, tomorrow we will be talking about comparable. Okay, what is comparable in detail here? We'll try to talk about it and understand. Clear? Great guys. Okay, so we shall wind up a session for today and catch up tomorrow with comparable topic. Okay, so thank you all. Take care. Bye bye. Have a nice day.